For the next stage, you see this problem. They are given like this. When you give like this for magnesium, ether means it is a Grignard reagent. Preparation of Grignard reagent. Any halide with the magnesium in the presence of ether means directly go for Grignard reagent. This is the answer. You see, very simple. This is the answer. That's all. Okay. Then this is A. Then what about when treated with water? You see, be careful. These type of questions will be repeated in other angle again and again. What should you do? Whenever you prepare a Grignard reagent and followed by water, what should you do? This is the answer. Like this. The alkyl or any group will combine with H, and these will be combined with OH. This is the technique. So what will do? The answer is, that's all. Very simple. This is the answer. That's all. Plus MgBrOH. So this is A and this is B. So, okay, this is over. You see the next one, they are given the RBr, but they are not telling about the R. Whether it is a methyl or ethyl or phenyl, no indication. But here it is given. You see the R is given. So that I am moving smoothly, very easy. But here the R is not given. It is a question. But you know something. When treated with magnesium means this is Grignard reagent. But we are not able to write because of unknown. But luckily they are given the product. This is very useful. Sir, what is this, sir? This is the deuterium oxide, heavy water. They are just trying to confuse you. Instead of water, they are giving the deuterium water. Okay, what is the function of water or deuterium water? It will add one H. See, this H, this D is added from D2O. This D, deuterium, D means not this D. Don't be confused. It's not in the question. This one is entirely from this one. This D means they are asking the question. This D means isotope of hydrogen. Okay. This D is obtained from deuterium oxide or heavy water. So you come back, slowly come back. You can analyze. So what will be this one? This is the answer. You see, this is the answer. Because this MgBr, it converts into D. Okay, if this is MgBr, then what will be the R? Very easy, you know that. This is the answer. You see? That's all. Don't write Mg here. Don't write Mg here. Now you follow the full reaction, you will have the understanding. See, when this compound is treated with magnesium, it gives a Grignard reagent. You see, magnesium bromide. When this compound treatment with deuterium oxide, again and again I am telling, the bond will break here, the D will join here and the OD will join here. That's why you are getting this compound. So, okay, this is over. What about this one? You see, they are given R1X. They are given R1X. Okay, but they are not telling the R1X. But when treated with magnesium, it gives the D, which on treatment with water gives E. You see, they are not giving the formula of the D also, they are not giving the formula of the E also. Then how could find? You see, very easy. How you are going to find? You take this compound. They given the product. From the product, you should find the reactant. That is very important. So basically, what will ask? From reactant to products. Here, product to reactants. So, okay, what does this mean? What does sodium ether means? That is your challenging one. It comes under naming reaction. What does it mean? It is nothing but Wood's reaction. What Wood's reaction says? R and R combines to form RR. So, this is a compound formed by the 2R. So, what you will have that idea? You break the compound. This is 1R and this is a 1R. If you break the compound, you can find the 2R. So, what about this one? This is the compound. You see, this is the compound. That's all. Why I am writing Br? Because in Wood's reaction, we have to go for Br. Or if they write X, you write X also. That is your wish. Sir, they written X means you can write X. X means anything. So, this is R1. Then, when treated with magnesium, you know that one. You convert it into Grignard agent. Whenever they give magnesium means you are converting into Grignard agent. That is D. When Grignard agent is treated with water, again you know what? The MgX will be converted into H. That's all. This group will be converted into H. I am writing here. You see, that's all. You see, that's all. The magnesium halide is converted into H because of the water. Because of the addition of water, this will be converted into H. That's all. Okay. This problem is over. Next one, you see this question, this is a formula, but no reaction with the chlorine in presence of darkness, but when you use light, you see the one word, only one monochloride, we are getting only one monochloride. If they say only one monochloride means, I cannot write like this. You see, I cannot write this. If I write the 5 carbon like this means, what does it indicate? We are having different carbon, so the product will be different. But they are warning you only one monochloride. Then what does it mean? All the hydrogens are, all the carbon are similar. How it can be similar? That like this. You see, this is a similar hydrocarbon, of course, cyclo. You see, in all carbon, we are having CH2. When you treat with chlorine, the presence of light, so this is the answer. That's all. Here or here or here, anywhere. All are similar. What is the name of this compound? You count the carbon. Don't have any tension. Count the carbon. 1, 2, 3, 4, 5. Pentane. But it is a cyclic. So, cyclopentane. Then what is the name of this compound? Chlorocyclopentane. Okay. Next question. Write all the possible isomer for C4H9O. C4 means butyl. C4H9 means you should write butyl. in chemistry, we are having 4 butyls. How we can have 4 butyl? Very simple. You see, first write the straight carbon. Write straight carbon, two types of straight carbon and 2 set of branch carbon. 2 set of straight and 2 set of branch. Here, the bromide will be the last one or in the middle one. Here, same concept. The bromide will be in the extreme, the bromide will be in the middle. These are the 4 compounds. But I have just written only the skeleton form. You should complete with the hydrogen. I will tell you. CH3, CH2, CH2, CH2. That's all. Don't write like this. This is the wrong one. Even though it's correct, they won't accept. What about this? CH3. What about here? Because of the group, CH. Only one H. CH2, CH3. Extreme means CH3. What about this? CH3, CH. Here, this is also an end. CH3. Like CH3, this is also CH3. Here, CH2. Here, CH3, CH3, CH3. What about this carbon? Very important. Sir, we are having 2 substituents. So, no hydrogen here. You should not write. You see, we are having 4 bonds. So, no hydrogen. That's all. Okay. Next question. Prepare 1 iodobutane from the following compounds. You see, these are slightly some technical questions. These are slightly some technical question. That is 6.7. Okay. Page number 181, 189. Sir. First question what? Prepare 1 iodobutane. First you write the butane. You see 1, 2, 3, 4. That's all. But 1 means this is a 1 butane. From what? But 1 all. You see? But 1 all. One, 2, 3, 4, but 1 all. This is the one question. Second question. Chlorobutane. Okay. From chlorobutane, all 1 chlorobutane. Then third one, but-1-ene. Somebody may feel the difficulty to write but-1-ene. You see, if you feel difficult in writing means, you first think about butane. You all know the formula of butane. Remove 2H. Remove 2H between 1 and 2. This is but-1-ene. This is but-1-ene. So, okay, this is a question they asked from butanol, then chloride, then from butane. Now, you see, OH is converted into I. You see, OH is converted into I. How it can be done? By adding PI3. You know that PCl3 means OH is converted into Cl. When you use Pi3 means OH is converted into I. That's all. Okay. Here chloride is converted into iodide. This is the concept. How chloride is converted into iodide? By adding sodium iodide. That's all. This is the Finkelson reaction. This is Finkelson reaction. Next one, you see, we are having a double bond. We are having a double bond. But here the bond is removed. So, how it is done? You see, for this type, I am writing for my convenient in the different style. You see, same formula, but I am writing like this. You see, both are same. You see, I am writing like this. Both are same. Okay, I am removing this. So, okay, how they converted this into this one? You see, we are having a double bond, all are converted to single bond. So, what happens? H here, I here. You see, H, I are added in this type. So, the reactant is HI, but what is the problem here? When you add I to the carbon having more hydrogen means it is against Markovnikov rule. It is against Markovnikov rule. So, what should I do? You should add peroxide. That is anti-Markovnikov rule. You should not only add HI, you should add peroxide. In that case, H will join here, I will join here to form N-butyl iodide. Or what will happen? Suppose if you forgot to write this peroxide means what will happen? The I will join here, H will join here, the compound will be entirely a different compound which is Markovnikov rule. But here you don't need Markovnikov rule, you need only an anti-Markovnikov rule. That's why I am adding peroxide. Next question. This is very simple. You all know that. What do you mean by apident nucleophile? It's a nucleophile attacking on both sides. For example, cyanide. You see, it can attack from carbon side, it can attack from the nitrogen side. That's all. When attack from the carbon side means it is a cyanide. When attack from the nitrogen side, it is known as isocyanide. So, it's all very easy question. Okay, next one. You see, which will react faster SN2 with HI? When I already told you, when anybody tells SN2 means 1 degree, it is favorable for 1 degree. You see, out of these two, this is 3 degree, this is 1 degree, so this is favorable. Out of these two, both are 1 degree. So, then what shall we do? Then you go for the halide. The size is small, bromide. The size is bigger. Iodide is a big size. So, the iodide due to the steric hindrance will come away very quickly when compared to bromide. So, this will go for SN2 mechanism. Well, now, we are going to the next conversion like this, which is given here, page number 190, question number 611. This is the first question, ethanol to but 1 wine. we are having 2 carbon, here we are having 4 carbon. So I am using this type of reaction. You see, first I am using SOCl2, the OH will be converted into Cl. But here we are having only 2 carbon. So I treat with acetylene having a triple bond. Why I am treating with acetylene? Because they are asking the triple bond compound. Because of the triple bond compound, I am selecting a triple bond reagent like acetylene. So it merges with this one to form but1Y. Second, ethane to ethene. What is the concept here? A single bond is converted into a double bond. That's all. So there should be some elimination. There should be some elimination of 2 atoms from 2 carbon. How it is done? You take ethane. First treat with bromine. The H will be substituted by Br. I already told you again and again and again. Whenever you use chlorine or bromine, H only will be replaced. Okay? But how? Why I am converting into bromide? Now I can do my technique. I can use my technique. What technique? Dehydrohalogenation. That's why I am converting into bromide. What is dehydrohalogenation? Removing the H from here and Br from here. So automatically that single bond is converted into a double bond. So this concept means is meant for dehydrohalogenation using alcoholic AOH. Okay, next question what? Propene to 1-nitropropane. You see, propene. But they want a single bond compound. There we are having a double bond, but they want a single bond. So what should I do? I treat with HBr. But that is also some difficulty. What is the difficulty here? When you treat with HBr directly, it will join like this. When you treat directly, it will add like this. Br in the middle, H in the end. But that is not required as per question. Why? They want the nitro in the last. They want the nitro in the last. So, you should add like this. You should add like this. But this is against Markovnikov rule. That's why you are adding peroxide. You are adding peroxide because against Markovnikov rule. So, H will join here, Br will add here. So, this is the compound. And this can be easily converted into NO2 by adding AgNO2 because Br will be substituted by NO2. Okay, next one. You see, toluene to benzyl alcohol. You see this compound, toluene to benzyl alcohol. What happens? How does it occur? One H is replaced by a OH. One H is replaced by a OH, but it cannot be done directly. So what we have to do? First to convert it into halide using chlorine, then you treat with sodium hydroxide or potassium hydroxide. But be careful, it should be an aqueous, not alcoholic. Alcoholic means it will eliminate. The whole thing becomes wrong. You should use aqueous potassium hydroxide so that the Cl will be converted into OH. Next question, you see here. Propene to propine. What is the concept here? A double bond is converted into a triple bond. They are converting a double bond into triple bond. How can be done? By removing the group. You see? By removing the 2 hydrogen here. But it is possible to remove 2 hydrogen? No. There's no chance of removing. So what I am doing is, I am treating with bromine. Here is one bromo. We'll add. Here is one bromo. Add. Because both are symmetry. No rules for Marconic of rule. Nothing Marconic. No for Marconic of rule. So add to Br like this. Now you can have two options. By adding two alkalic AOH, one alkalic OH is to remove this HBr and the another alkalic AOH to remove this HBr. So automatically you have a triple bond like this. You will have a triple bond. You see, like this. That's all. Or you can use zinc. When you use the zinc, what will happen? No, this cannot be used. This is wrong one. When you use zinc, what will happen? These two bromide will be eliminated. These two bromide will eliminate means it only forms a double bond. So, when you use two alkyl KOH, one for this to form a double bond and one for this to remove this OH to form triple bond. So, we are removing 2 times HBr. Next question. You see, they are asking ethanol to fluoride. Fluoride means you should go for Schwarz reaction. What the Schwarz says? He converts, you see, bromide into fluoride. He is converting bromide into fluoride, but they are given alcohol. So, it is very simple. You convert the alcohol into bromide by using PBr3. You see, these compounds, can be used for converting OH into Cl or OH into Br or OH into I. So, these can be used to convert hydroxy group to the corresponding halides. So, that's why they are using phosphorus tribromide. So, that OH is converted into Br. Br conversion to F is very simple. We go for Schwarz reaction. Okay. We are going to the next question. Bromomethane to acetone. You see, we are having 1 carbon here, we are having 3 carbon here. In organic chemistry, how can you increase the carbon? One, we are having Wood's reaction, but it is not possible here because we are getting we want ketone, we want acetone. So, Wood's reaction is only possible for halide to alkanes. So, you should drop the Wood's reaction. Is there any other method to increase the carbon? Yes, Grignard agent. Grignard agent can convert one lower to higher. You see, you are taking the methyl bromide, you treat with magnesium, we are getting methyl magnesium bromide. After that, you can directly treat it with methyl cyanide to get acetone, or somebody has already learned another concept. They can use that one. What concept? Sir, treating the Grignard with the acetaldehyde, it gives 2-degree alcohol. Acetaldehyde with the Grignard in 2-degree, that is isopropyl alcohol. Isopropyl alcohol on oxidation gives acetone. That's true way. You decide which is very easy. That's all. Next question. You see, but 1-ene to but 2-ene. They are shifting the double bond. In this conversion, what they are trying to say is the double bond in the first carbon is shifted to the second carbon. How it can be done? You treat with HBr. You first treat with the HBr it will join according to Markovnikov rule. What does Markovnikov rule says? The Br will join here, having the least number of hydrogen, and the H will join here. So this is the formula. Then you remove to HBr. You know the technique using alcoholic KOH. This is very, very important. The alcohol is very important because only alcoholic KOH can remove HBr. So I am removing this Br and the hydrogen from this H. You see, this is not, you should not write like this, but for understanding I am writing. The Br is removed from this carbon and the H is removed from this carbon. So there is a double bond here. That's all. Then what is the next one? You see, chloroethane. Ethane means 2 carbon, butane means 4 carbon, double the amount. Very easy because already they given halide. So you select Wood's reaction, treated with sodium in the presence of ether, the 2 ethyl groups merge. The 2 ethyl groups merge to form N-butane. That's all. This is, see, 2 methyl groups, they combine to form N-butane. Then what about the next one? Benzene to biphenyl. Here also you are doubling the ring. So again, phytic reactions, like Woods is the phytic. But what is the drawback? You don't have the halide. So you convert into halide. I am doing this to favor for phytic reaction. So I am converting to halide like bromide, then treat with sodium in presence of ether. 2-phenyl will combine to form biphenyl. Okay, that's all.